So, to talk a little bit about me, I guess. I'm a director of regional security at a large international Fortune 1000 company. Don't let the D word fool you. I am technical and actually do work, so it's a little interesting. Not used to that, I guess. So I have heavy experience with penetration testing, exploitation, web application security, wireless, and physical security. Prior to my current job as a director, I was a VP and partner of a fairly large information security consulting company. And all we would do is basically break in everything. I'm the creator of the Social Engineering Toolkit. Has anybody ever used that? Hey, it's good to see you. Anybody ever used Fast Track? I created that too. Have a military background. I was in the intelligence community. I was in the United States Marine Corps. I did a couple of tours in Iraq and Afghanistan and intelligence-related activities. So that's pretty good. Now, before I get started on my original conversation, just kind of want to talk about a little bit of different Metasploit flags that weren't necessarily covered that could definitely be important when you're going through something. Now, if you saw in Martin's presentation, he used MSO 8067. Now, that's specific. Were you actually going for something that I think you were?
I wasn't in the office.
You're going for the SAC Maniac? One thing with MSO 8067 is the actual exploit itself is very dependent on operating system. Reason being is because it uses a method for data execution prevention bypass that's very specific on memory addresses. If you saw in Elliot's presentation, he was hard coding specific memory addresses in to do the jump ESP. Well, similarly to MSO 8067, based off of what different service pack you're using, completely changes memory addresses. So when you see an exploit that's out, you'll see an exploit out for Windows XP Service Pack 1, Windows XP Service Pack 2, Server 2001, Service Pack, or Server 2003, Service Pack 1, Service Pack 2. Reason being is, again, because you need those specific memory addresses in there. Now, Metasploit does a pretty good job of finding what version of the operating system that's currently running, but sometimes it can't. So I wanted to show you something really neat. And I'm going to talk to demo gods. I'm just going to basically do all live demos here. So
we'll sacrifice Elliot to the demo gods.
Yeah, where's Elliot? So we're going to set this payload up. We'll do interpreter. Let's do bind. And we're going to target this Server 2003 Service Pack 1. Now, the actual exploit itself, if I do show options, it's set up properly, right? So I have my R host, I got my L port that I'm going to go onto, and I'm doing a bind interpreter console. Well, when I go to exploit it, look what happens. See here, fingerprint window, Server 2003, Service Pack 1, language unknown. Could not determine the name of the exact language pack, exploit completed, no section was created. So in this instance, we don't have a successful exploit, right? Obviously, it didn't exploit the system. Reason being is, based off of the different language packs, changes the memory locations. So what you can do is you do show targets. So you can see the different target versions that are up there. Now, 99.9% of the time, you're going to be targeting English. So you can probably assume that this server is going to be running English. So let's go for this. And we're going to specify Server 2003 Service Pack 1 English. And if you look in parentheses, it says NX or no NX. NX is just abbreviated for DEP or no DEP. With Server 2003 Service Pack 1, Service Pack 2, and Windows XP Service Pack 2, Service Pack 3, DEP is enabled by default. So 99% of the time, you're going to have a pretty good successful clip if you go after the DEP enabled operating systems. So we'll just set our target to 7. Now we're going to exploit it. Boom. So, just so you know, when you run an exploit, there's that target availability. Again, the auto targeting is generally pretty good, but again, you're not going to always have that. And one thing I also want to show too is in Martin's presentation, he shows you how you migrate to a different process, right? So, say for example, you're doing a client-side exploit, and I'll show you a lot of those with Set. But when you're going through and doing client exploits, as you go through and you get that interpreter session, you hit the X button, the browser closes, the process that you're running on is automatically going to close and shut down, so you no longer have your session, right? So you have to be very quick. If a user sees a pop-up box happen, or if the Internet Explorer starts running, pretty crummy, what he's going to do is he's going to close it out, right? So what you can do is if you go to Show Advanced, you see in here there's this auto run script flag. You can just do set auto run script, and do migrate-f. So what's going to happen now when we exploit this, it's going to open up a hidden process, notepad.exe, and automatically migrates it for us. So now when that user goes to close that browser, we'll have a separate process running. We don't have to worry about them closing it out or us losing our session. So just different options you can mess with. All right. Where are we at here? So I'll talk a little bit about the Social Engineering Toolkit first of all. The Social Engineering Toolkit, if you don't know, social engineering is a very, very heavily used attack vector right now. And why not? We're generally pretty dumb to these types of attacks. I mean, our human behavior, the way we behave on a daily basis, is pretty much the same for almost every individual. We're generally trusting of an individual until they violate that trust or a certain part of aspects that make them look shady. So Martin came in and he was walking through and he's got all these tattoos on me and he comes in looking all mean. Well, obviously my guard's going to be up. But if I walk in and I'm in a suit and tie, I look important, your guard's going to be down. And I'll talk a little about that in a little bit. The social engineering attacks are really on the all-time high. If you looked at and I hate to use the media as this, but the Aurora attack. The Aurora attack was Google got compromised, got breached by hackers. Reason being is because of social networks and the trust factor that they have with their friends. It looks like the breach originally came from a social network site where they hacked friends of executives in Google, and then they were able to basically deliver payloads to Google, compromise them, and have full access to some aspects of their network. So, these attacks are very, very targeted. So has everybody heard of apt? Everybody's heard of apt?
Cordelia?
Apt, what? So advanced persistent threat. I do a lot of work with a lot of different agencies out there, and not to use a buzzword, but advanced persistent threat is definitely out there. I mean, there's state-sponsored organizations that are out there and always trying to attack us. I heard one of the gentlemen from one of the agencies say, hey, why would well, let's take an individual who works for a corporation in the security department, a company. I'll pick on you. How many people do you have in your team for security? 2. How many do you got in your 15? China says, hey, I need this division of 1,000 people to target this organization and steal their intellectual property. So you have 2, or 15, and they have 1,000. Who's going to win? Probably not the 15, unless you got me on the team. No, I'm kidding. But to be perfectly honest, it really is a serious threat out there. The intellectual property game is big for them. Why would I start up a paint business when I can just steal the paint recipes and start my own? Or why would I, create a content filtering company when I can just steal my own code and do that? So there's actually a funny story. One of the I can't remember the name of the company, but there was a content filtering company that reported a breach, and they're able to trace it back to China, which denied it, of course, because they didn't do it. And 6 months later, that code was in the Great Firewall of China. So my question to them is, how the heck do they handle updates? I mean, do they rehack them and then steal the code and then push the updates? I don't know. It's pretty complex. So why is it so effective? Well, because we're human. We're programmed from birth and through our lives to act and behave a certain way. Salespeople utilize social engineering attacks to gain our business, right? This new security product is going to protect you against 100% of the hackers out there. Or this new intrusion prevention system will absolutely detect the advanced persistent threats out there. Or we'll protect your cloud computing. All of these out there are sales jargons to make us feel a false sense of security, or maybe it does do a decent job. But in the ultimate name, we try to con people into doing what we like, right? So if you aren't doing social engineering attacks as part of your normal security program, you're really missing out on a big attack vector. For me, if I'm doing a penetration test, I'm not going to go and try to attack a network-based buffer overflow. I'm not going to try to hack the latest and greatest web application firewall or a web application. I'm going to spoof my number. I'm going to call in and say, hey, I'm the CEO of your company. I need you to download something for me. Or I'm IT, or I'm your security administrator. Hey, I noticed you've been visiting some strange sites, and it looks like you're compromised. Can you go and download this file for me? Well, me, I'm like, yeah, where I gotta go? That's just the way we are. So talking a little bit about social engineering, if you haven't been here yet, really great resource. Social-engineer.org. Has everybody been there? Good. That's awesome to hear. Social-engineer.org is really just a all-in-one resource and framework for social engineering. We also have a podcast, which I skipped ahead 2 slides. And the podcast itself, when we get high-end people that specialize in human behavior, when we get PhDs from Harvard, people that have published 20 books on human behavior, and the whole goal is to really educate people of really how we're programming. The latest podcast that we just recorded 2 days ago should be out within the next week or two. We had a guy, name's escaping me for some reason, but he published like 20 books on human behavior. And he asked me on the phone, he's like, hey, Dave, look to the left of you. And I looked to my left, he's like, is your desk in a complete array? And I got papers everywhere, I got my pen, I got my book, just all this stuff spread across my desk. He's like, okay, look to your right. What's to my right? And he's like, what's there? I'm like, well, not really much, it's all orderly and everything like that. He's like, all right, well, you're left-handed. I'm like, yeah. He's like, okay, so now I know by going to your desk or what you do in your behavior that you're a left-handed person. He's like, did you know that there's a higher success rate if you talk or whisper something into someone's left ear and they're left-handed than there is with their right and the right ear and right-handed. They're left-handed. Because based on what part of the brain actually interprets what you're going to do will actually make you decide a certain way, generally better than the other way. So you have like an 85% chance in hearing my left ear to agree with you than 60% in my right ear, which is pretty interesting. You guys publish like an insane amount of books, so I don't know. It can be fake, who knows? But really good resource to go through that. The social engineer framework really has basically everything you possibly need to perform social engineering within your organization or learn more about it. Really great resource if you haven't checked it out. So I released a new version of SetNot Accountant. So it was about a few weeks ago. I always come up with crazy names. Last one was it Rise of the Pink Pirate or something? I don't know, I'll come up with these. And a long story, DEFCON 16 I was presenting on Fast Track, and the offensive security team decided that it'd be pretty funny to launch a lot of lemons at me. So while I was on stage at DEFCON, I had about 70 lemons launched at me, and one happened to hit me right across the face, which then just disoriented me, and I had no idea what I was doing. So, yeah. So basically, it's open source, it's free. You can do what you want to.
It was like a lemon party?
What?
It was like a lemon party?
It was like what's that? Right on cue. So Set is open source. It's purely Python driven. Do what you want to with it. If you want to rename it and call it your own tool and tell your company that you wrote it, go for it. I don't care. It's free. It integrates with Metasploit primarily because obviously Metasploit is a framework, right? Everything you saw there from building exploits to launching exploits to creating your own payloads, because it's a framework. So building stuff into it is what it's designed to do. So it's payload repositories, it's client-side exploits, everything like that. You don't want to recreate the wheel because those guys are much smarter when it comes to that, focus on that, and the framework is absolutely useful for that. It's multiple attack vectors specifically designed for social engineering, hence the social engineering toolkit. It's for good, not bad. So help pen testers and organizations test their security program. Who here is bad? No. Hey, so everybody here is good, so we can at least Martin. So let's talk a little bit about the different set attack vectors. There's a spearfishing attack. And everybody knows what spearfishing is, hopefully. It's just targeted attacks against an organization, either via email or other methods, in order to coax them into doing something. Whether or not you're double-clicking an exe or a PDF or, whatever you're doing to compromise the system, the spearfishing attack will explain that. Definitely help you out. The web attacks, this is probably my favorite aspect of the social engineering toolkit. The web attack vectors, pretty dangerous. I'll talk about that in a few minutes. The malicious payload, malicious USB, DVD, and CD. Really simple, basic attack, but it'll definitely grow over time. This is new in version 0.5. But it'll automatically create a auto-run based USB, DVD, or CD for you so that you can distribute them, and then when they go and insert their computer, it drops a Metasploit payload and they compromise it. So again, all around social engineering. So new in version SetNot 05, which is my favorite version right now. Well, I guess there is one. But the Credential Harvester. I want to show you a quick example of this one. And by the way, Set is in Backtrack by default, it's under the /pentest/exploit/set, and then it's actually all cap letters in there. So it's uppercase set. First thing you want to do when you get set, if you're using just a standard version of the backtrack, is you want to update it. And similarly to Metasploit, you just type in svn update. And that will go and pull down the latest version of set for you. Now to run set, just type in set. Now set is a menu-driven tool. So if you notice and you're familiar with Fast Track, the interactive mode is pretty much the same thing as this. I prefer menu-driven, type attack vector. Command lines get confusing. So when I program set, I did it from this method. And so with set, we'll go through the web attack vector first, and the credential harvester. This is specifically for if you're targeting an organization and you can get people to click a link or a browser or your site. A lot of times what I'll do it for is entice a victim, either through calling them up or it integrates with an Ettercap and a bunch of other things in order to get them to click on your site and compromise you. So first thing we're going to do is we're going to do the site cloner. And here's where the attack starts to get potentially dangerous. So what you can do is you can clone any website you want to on the internet. So let's pick on Google. And we're going to do the credential harvester method. So you see here I selected the site cloner. I clicked on the credential harvester method. And then we're going to go ahead and clone Gmail. So clone it. And all we do is hit enter. So this is my attacker machine. So I have a Python-based web server running that will handle all the requests for us. Now, to show you what's going to happen is somehow I entice a victim. Again, either you email them or some other method. And we're going to go to this website. Now you see, it loaded up pretty quickly. We have a website here that looks exactly like Gmail, right? You need every indication that it is Gmail. Type in my username. I type it in, I hit enter. And if you look here, oh, that's weird, brought me back to Google, okay? And if you look at the top here, where am I? Google. I'm at Google. However, on our other end, it harvested all of our credentials for us. So you can see here I got my username field, and I got my password field. So that's nice. Now when you control C out of here, it will export automatically a report format for you. So it'll do HTML-based formatting and also do XML-based formatting if you want to create a tool off of it. Go right ahead. But what's nice about this is if you're doing a mass phishing attack against someone and you get, say, 50 people, it is multi-threaded, so it will handle multiple connections and things like that. It'll generate a nice report for you, and I'll just show you a really quick output of that report. So it generates a nice report for us. So you can see here, it'll show you, it gives you a little definition of the social engineering tool, the report format, and then it shows everything in here. So you can see the email and the password field. These are all the post parameters. The set tries to do a good job of determining what the username and password fields are and highlight those for you, but again, it's not perfect, so I include all of the post parameters in there for you. Now you can see that line down here. There's where you see multiple users, breaking on different ones, so I'll be able to harvest it all for you. Pretty slick. So one important aspect about set is the configuration file. I get a lot of questions like, well, hey, if I'm using, set, when I was doing that attack, set automatically detected my IP address and put it into the tool for me. There's a lot of times where you might have multiple interfaces, and you might have a public IP address on one and your internal on the other, and it uses whatever internet connection to get out to the internet. So you can configure it manually, and it's all done through the set config file. And it's the most important, probably, aspect of customizing set in the tool. That's under config/set_config. And you go there, and here it'll, a few different options. You have the Metasploit path. It does integrate into Ettercap, so if you wanted to do DNS poisoning of the entire, if you're on the internal network, you can do DNS cache poisoning. And so whenever they go to browse Google, it actually goes to your malicious set, and they never know the difference. So you just have to turn that on. It also integrates into SendMail. By default, Backtrack has SendMail installed on it. So from a SendMail perspective, you just turn that on, and then you can actually spoof source addresses, things like that into it. The Web Attack email, in that prior example that you saw here, when I was actually going through and doing the credential harvesting, if you turn this on, and we'll go ahead and do that, it'll actually allow you to send emails after the site has been created. So you create your malicious site, you clone everything, you turn your Web Attack email on, it'll then prompt you to, if you want to send an email out to a bunch of people. Now you can do a mass email, single email addresses, whatever you want to. I won't get into the self-sign applet yet. And here's the auto detect. This is where you turn that off if you didn't want it to automatically detect your IP address. Just turn it off, and then you can enter in whatever you want to. So let's do that same exact attack we just did before. So we're going to do the Web Attack, Site Cloner, Credential Harvester. We're going to clone Gmail. Someday. And if you see here, we're now prompted for passwords. So we can send a single email address or a mass email. Specific format is, just username by email address by email address. So email address, enter, email address, enter, email address, enter, etc. So we'll send it to my email address. And here you can either it integrates into Gmail, so if you have a Gmail account, it'll send it from there. Or if you want to use your own relay server, so for example, you have an SMTP server, it provides both credentials or anonymous. If you had SendMail here, it automatically prompted for a SendMail email as well. But we'll just go ahead and use email. We'll use my email address. So it will go through and send the email for us. And if you go back to our email account here, so I'm definitely going to check this website out because it says, dude, you have to check it out. And then that's where I got logged out. Okay. I'm not going to actually put my username and password there. But hey, I'm actually authenticated already, so it just redirects me back to Gmail like I was normally there. Cool. And on the back end, I get all of the credentials harvested. So, whatever you can figure out a way to coach somebody into clicking your site is obviously a good thing. So that was new in 4.5. Now, one attack I want to talk about is the Java applet attack, and that's probably my favorite one. And the reason being is everybody traditionally on their Windows system, or Linux or OS X, has Java installed, right? I mean, Java is a pretty integral component of the internet. So with Java, there's this awesome non-vulnerability, as they call it, where you can create a Java applet, self-sign it to whatever you want to, and then when a victim goes to browse that site, it's going to say, hey, Microsoft is trying to have you run this Java applet. Do you trust them? Well, of course we're going to trust Microsoft. I would, right? Or Google, or China. So we're going to turn this self-signed Java applet on. What that's going to do is by default, the Java applet will be signed by Microsoft. Sorry, Microsoft. And then if you want to spoof it to somebody else, like Google or whomever, just turn this on and you can specify it. I will turn the web config off, the web attack off, as you get the idea. If you send emails to individuals, you can get them to click on it. So we'll do the website attack vector. We're going to clone a site again. And we're going to do the Java applet attack method. I lost my internet. No. Okay. So, what's your first name? Just say Google. It's Google. Okay, so we just created our self-signed Java app, but we're going to clone Google.com. And here's where we start to get into the payload selection. Now, what I've done with Set is I've incorporated pretty much every Metasploit attack you can possibly imagine into Set as well, the payload creation, everything else, to get around antivirus. And it's funny because when I presented at ShroomCon and I released this, they released like 6 signatures for my tool. So I obfuscated everything to hell, so everything that set does is completely random and unique. And so it gets past all of them now. So just to make sure, antivirus companies, good job. Yeah. So we're going to select our default, which is going to be interpreter. And we're going to use the default. Now, in version 7.05, I took calculator.exe, calc.exe, and what I found was if you're going to code cave or do that backdoor, the -K or whatever, if you're using command type applications like ping or something that revolves around being inside a command prompt, what will happen is the way that Metasploit injects its payload into it, that the user would get a pop-up that looks like a blank command shell. Obviously, that would probably be a good indicator that something not good is happening. I don't know, probably not. People would just be like, oh, I got to minimize that. I mean, I'm sure the website needed that. I wouldn't. So what I did was I found that things that don't use console applications, like calc.exe, for example, is a specific GUI. If you code cave those and you don't specify the -K flag, nothing is ever presented to the user ever. So I don't want the executable to run properly, but I also don't want any type of console application. So what I did was I took calc.exe, I foobarred it a bit so that the calc wouldn't load, and then whenever you generate a backdoor, it does that. Currently, none of the antivirus vendors are picking this up, so you pretty much have a 0 out of 42 clip, which is a good thing. Okay. And I'm just going to hit enter. So we're going to use the default, but you can do multi-encoder. Multi-encoder will Shikata-Guy-nate it. It'll alpha encode it. It'll Shikata-Guy-nate it again and do a bunch of other encodings to try to get around antivirus if you didn't want to do the binary. You can also specify your own encoding if you want to, whatever you really want to do. We can also enter the port here. So I'll just use the default, which is 443. But you can specify whatever port you want the actual payload listener to be running on. So it's encoded. Now, one thing about this attack is it's not only for Windows. It does work on Linux and it does work on OS X, so it's multi-platform. So based off of what you're browsing at, your user agent, it'll say, oh, hey, you're Linux, okay, I'm going to shoot you over this payload. Or hey, you're Mac, I'm going to shoot you over this payload. Or hey, you're Windows, I'm going to shoot you over a whole bunch of payloads. So we're not going to do those right now. By the way, if anybody has any questions, I'm going through this, feel free. So we got our payload handler through Metasploit. Should look familiar, right? One thing I did add is it automatically does migrate. So when you go and exploit this, it will migrate to a different process. So if the user does close the browser, you're still okay. Kind of make sure about that. Yeah. So we'll go and browse to our website. Now, first time you load this, it can be a little slow because it doesn't cache it the very first time. But afterwards, it's very fast. And it is a multi-threaded HTTP server, so turn it on very quick. Oh, that's quick. Okay. So we get this publisher of Microsoft, which I thought was for Google, but so we get this payload that says, hey, Microsoft wants you to publish this application. Do you trust them? And of course, we trust Microsoft, so we will run this. And so when we run it, everything's looking good. We know we have Google. Now it's taking a little bit longer for some reason. Like I said, the first time you use this, it's a little bit slow. All right, sacrifice Elliot.
Huh?
Sacrifice Elliot.
Super weak.
Let me refresh this real quick here. Well, hey, I got video backup, so. let's skip through this a little bit. We already done this. We're going to send an email. And we're going to look at that email. And so we get this published, Java applet from Google. We're going to run it. Oh. That was a back shot. That's not even manly, dude. Seriously. So we run it. Now, one thing to notice, what happened? Anybody notice what happened?
Google.
We're at Google. So when the payload executed, it redirected us back to the legitimate Google site. So the user actually never saw that he was anywhere else other than Google. Now, if I'm like, oh, hey, I'm at Google, cool. I'm going to go in and I'm going to type some stuff and use it. It's all good. So, it browses Google normally, everything's good. However, on our attacker machine, we got an interpreter account, so we fully compromised that machine. So, if it ever worked.
Is there any way to use Google API calls so when it redirects to the Google site, you can actually, like when they put in their login, it will automatically already log them in? You can use like an API key or anything?
Not necessarily. What you can do is when you harvest the actual credentials itself, you can refresh a post from the user account to the original site. That's just a pain. And when I was writing the Credential Harvester and I started actually programming that, it was a real big pain. So it only worked on certain sites.
If they had chosen the stay logged in feature,
Yeah.
after they submit the password, would the very next time they see automatically be Google because they already had the...
Yes.
Okay.
Yes. So if they're already logged in, it would obviously do it. Obviously, this is just an example using Google, but you definitely don't want to use it from a Google perspective. You use this when you're trying to go after your organization, right? So that was that. Next is in the website attack vector. You also got the site cloning, and we're going to go ahead and use the Metasploit browser exploit method. That one takes Metasploit exploits, and we didn't really cover them too well. So let's really go really fast into that. So browser-based exploits, if you're not familiar with them, as soon as you go to browse a website, it triggers a vulnerability within your specific browser and then causes what we call generally a heap overflow, a heap-based overflow. A lot of times what we saw with what Elliot was talking about was a stack-based, right? So with a heap, it's a little bit different. Heap is dynamic memory. It's dynamic allocated memory. So what ends up happening is a heap will grow or shrink based off of its requirements, what it needs in order for it to use it. It's just kind of like garbage data, stuff that stores in the heap in order to use it. With browser overflows or exploits, what ends up happening, and this is a pretty cool method, a guy named Skyline came up with it, I think in like 2002 or 2003 or something like that. He worked for Microsoft. I taught him how to play craps and bakes, which is kind of cool. With heap-based overflows, what ends up happening is, you think about it, there's just a garbage amount of data. The memory addresses are completely random. You have no idea where you're at in the heap. It's going to be different every single time. It's just that kind of space that's used for the application or information that you're entering, right? So what you can do with client-side exploits is it grows the heap. So say, for example, you have 4 gigs of RAM. It'll continuously grow the heap until you hit that 4 gigs of RAM. So if you look at when a browser exploit is actually firing off and you look at your task manager, you'll see your RAM utilization go all the way up to max. What's happening is it's filling your heap with knobs and filling your heap with shellcode. So what ends up happening is you blindly fire into the heap. You don't know where you're going. You're going somewhere in the heap. You fire into the heap, you have about a 92% chance of hitting your knobs, and then down your shellcode and execute your shellcode, and boom, you have access to the system. And you also bypass that, ASLR, stack canary protection, all of the preventative measures that are in place generally, right? So heap-based exploits are a much more reliable method from exploiting browsers than any type of stack overflow would be. So what's cool about that though is it generally has anywhere between like an 87% and 92% success rate. Reason being is what happens if you jump halfway into your shellcode or halfway into some other garbage data that's left over from the application, it'll crash. So you'll see Internet Explorer actually crash sometimes. It's just a kind of FYI on heap-based exploits. But Metasploit has a ton of browser exploits based within it. A lot of them are for Internet Explorer. But you go through and you can see a bunch of different types of browser exploits. Now let's search for the Aurora one because that's always the most popular, right? So to use one, you just use the same as every other exploit. Now we're going to set our payload as a bind. We can do reverse if you want to, but And I generally use 443 or 80 because it's generally allowed outbound. Now, does anybody here do strict egress filtering on their network? You know, i.e., I don't allow very many ports from my clients, my customer base, or my users going outbound to the internet. Right? We got a few. Do we allow any ports at all for those users to be able to connect outbound? We can. We have to. I mean, it's just. So Microsoft. So Metasploit came out with this thing called all ports, which is a pretty slick method. And what the all port payload does is it actually tries connecting out every single port going outbound. So from 1 to 65,000, whatever. So if you have egress filtering and you allow one port out, it's going to find it and it's going to allow it out.
Does it do it incrementally or does it do it random?
It's random, I believe. I'm not sure offhand. I can't remember. When he blog posted about it, I'm pretty sure he said it was random, but it takes a very long time. So it can take 10 minutes because it fires off 5,000 some odd ports. So if you're not monitoring, if you're monitoring your egress, and probably notice 65,000 different attempts. But you never know. But it's very good for that. Second off, a lot of people say, well, hey, we filter. HTTP, we inspect, HTTP and HTTPS traffic, making sure that it's legitimate HTTP traffic, right? So Metasploit released a HTTP-based payload. So we have somewhere, I'll just pull from something. We have HTTP and HTTPS-based payloads. So the actual consoles will fully function over an HTTP-based connection. So if you're inspecting HTTP traffic or inspecting HTTPS traffic, i.e. SSL termination, it will let you basically still go by that, which is awesome. So we're just going to do a normal payload. And we don't have an RHOST in this specific example. If you look here, what Metasploit will do is it will create its own HTTP server on port 8080 and with a URI path of something random. So what I generally do is obviously set my server port to 80 because I don't know how I'm going to get somebody to connect me on 8080. Okay. Or you can set URI path and also set the URI path to root. So what's going to happen is it's going to set up a web server. As soon as someone connects to me, it will basically go ahead and execute that. Now, if you're going through and you're doing these types of attacks, I'll show you Set does it automatically for you. But I mean, you can always just inject an iframe into a site you compromise or something like that. So if you're going in and you're hacking your company and you compromise a website, you inject an iframe into there. Every single time someone goes, and I only recommend doing this in internal, obviously you don't want customers getting hacked. But every time someone goes to visit that site, that iframe will load and automatically point to Metasploit and start exploiting the system for you automatically without them ever knowing about it. So you exploit it, and we're running a specific HTTP server. We'll go ahead and run it. And a person gets this little box here, but there's nothing really exciting going on, right? However, on the other side, we got an interpreter console. Potentially. Yeah, it's just being a little slow. But we were able to center stage, and eventually the interpreter console would come up. Any questions on browser exploits?
I managed to get my browser to do the actual exploit, and it said it connected to it, but I can't get the interpreter to actually do anything.
What do you mean? Like, did you get an interpreter console?
No, it said it connected, but it didn't do anything after that, like the other.
Did it say exploit completed, but not? Or did you actually get the interpreter console?
It said that session 1 open.
So then, okay, so if you get the session 1 opened, what ends up happening is you're running it in the background. So if you do sessions-L, you won't see anything there. You see that session active?
Yeah.
You do sessions-I and the number of that specific session. That'll interact you with that specific session.
Yep.
Cool. So now you have a interpreter console. Any questions on that?
Is there at least one exploit for each browser?
Yes. Well, I just have generally yes. There's Firefox and Metasploit. I believe there's Safari. There's Opera. So yes, there are exploits pretty much for every single browser out there. Obviously, there's more for Internet Explorer than there is for Firefox or Opera or Safari. But the majority of them, they're pretty much the old the most latest Firefox one was for 3.5. It was a font tag exploit. So it's going to be, you got to make sure you're out of date with that type of stuff. That's why I don't necessarily go the browser exploit route. I mean, the chances are the person's going to be patched, right? Okay, so that was kind of a walking that one. But chances are that the majority of them are going to be patched. Say Internet Explorer is generally going to be patched. When you get that pop-up saying, "Hey, you should probably patch your system," we're going to patch it, right? So why do that when you can do the Java applet method? The Java applet method isn't a bug as far as Sun is concerned. It's not a flaw. So, I mean, someone gets this pop-up that says, "Hey, are you going to trust Google?" Of course I'm going to trust Google. So I'm going to run it. And I guarantee you it works. I did a survey at SetNot, and 4 people raised their hand about using the Java applet. And I said, "What was your success rate?" They said 100%. Mick Douglas from Paul.com said, basically I got told I can't even use Set anymore because I'm just rubbing it in. So, you're going to have 100% success rate with it pretty much, unless it's us, right? We're not going to click, and run a Java app from Google. So I would. So let's go to the Metasploit browser attack vector within Set. Same exact step. We're going to go through the website attack, right? We're going to go ahead and we're going to select the Metasploit browser attack, and we're going to clone Gmail. Surprise, surprise. Now, in this instance, what Set's doing in all these attack vectors is it's grabbing a site similar to like a wget or something like that, right? And it goes ahead and it automatically rewrites the site for you. So it injects the Java applet into the website itself, or it rewrites the Metasploit exploit into the file itself. So it does it automatically for you. Here it has the list of the built-in exploits that Set uses. These are the most reliable ones that I'm able to find. As soon as an SVN update comes up for a new exploit, it's generally in Set within an hour or so. So it's usually pretty fast. But again, we'll go ahead and use the Aurora attack, and we'll go the same route. We'll go interpreter. And we have everything running here. And we're going to go ahead and run the site. And you see here, it looks like there we go. Like I said, 82% clip, right? A lot of times what will happen too is, if you notice, the first time I did it, I did get a shell, but it may have corrupted my stack, so I might be kind of hosed. Sometimes not. So in this instance, we have our interpreter session open, and we fully compromise it, and the user thinks he's just logging into Gmail. Bummer. So here, if you did session/shell, if you notice, we're not running as an interpreter console right now, right? It's running all these in the background. Reason being is, what happens if you get 50 people that browse your site, or 60 people? You're going to have 60 shells. You don't want to interact with them every single time it opens. So it'll list all of them there for you. So you just do a session/shell, and you can see here, I'm running as interpreter console in session 1, right? So, and understanding the ID here, so you see ID 1, I'm just going to interact with 1. If I had 70, I would interact with 67 or whatever you want to. So I'm in, and I'm running a shell. All good. If you notice, there is nothing popping up, which means my payload was successfully code-caved as a calc, never got detected, and we're all set. Any questions on that? Good.
Don't trust emails from fake
You talked about that with that just browsing the site. You didn't do anything else.
Nothing else. Yeah, just browse the site. That was it. So to kind of recap a little bit, the Credential Harvester, I kind of went completely away from my slides, which is always good. The Credential Harvester is new to version 0.5. Allows you to clone a website, automatically rewrite it, the post parameters, intercept them, and then redirect the user back to the original site. The Thomas Worth attack vector, I want to talk about this. The Java applet itself is an unpublished Java applet. It hasn't been published anywhere else. One of the guys that is a good advocate of Set came to me and was like, hey, I got this awesome Java applet that's multi-browser. You want to incorporate it into Set? Yeah, sure. That sounds good. So we kind of went through some different revisions, got it incorporated into Set. So it is now obfuscated heavily so that antivirus doesn't pick it up. So spearfishing. Spearfishing attack vector is fairly straightforward, as you can probably anticipate. And that's option 1, so we'll go ahead and select it. We're going to perform a mass email attack. Now, one thing I want to show you that is Set comes built in with different templates. So templates that you can use in a social engineering aspect. So if there's something that you can foresee yourself using multiple times, you can create your own template. So you select the read and name the author. So name cheese, and say, hey, dude, check this out. And we'll Control-C when we're done. Now that specific template would now be saved within Set, so every time you open it up, you'll always have that template in there. I actually closed it out without finishing the body, so I messed up there. But, so we're going to perform a mass email attack. And the mass email attacks use file format bugs. And what file format bugs are, it's very similar to what you saw with Elliot. Instead of it being remote, it's local on your system, right? So when they open up a PDF, or they open up a Word document, or they open up something, it automatically compromises their computer depending on if they're vulnerable to that specific attack. One thing I will mention is that the Adobe PDF embedded exe is probably your most reliable method of attack. Reason being is because it's not an exploit. Again, it's not criticized as an exploit. So when they go to open up the PDF, there's an executable actually inside the contents of that document. So as soon as they open it, it executes the PDF and then they're compromised. So kind of flaw. So we'll just go ahead and do the JPEG exploit, Adobe exploit. It's one of the most reliable ones for older versions. We're going to select an interpreter versus TCP. Have it connect back to us at 443. The guys in my office hate me, by the way, with this tool. Never trusted anything. So this menu should look a little bit familiar. We're going to email a single email address. We're going to use a predefined template, or you can use a one-time template that you just don't want to use again. So we've got a couple ones here. You got baby pics, strange internet usage from your computer, Dan Brown's annual demons, computer issues, status report. We'll just do computer issue, and I'm going to send it to myself. I use Gmail. What's that?
It's hard to trust them.
So we set up a listener. It's automatically going to migrate for us too, so when they close Adobe, it's not going to be a problem. And we'll go ahead and open email. Someday. Wait, I got the video prepped. So we got it. We know that there's a PDF here. Now, one thing to note too, if you view it, it's not going to hurt your computer because it's all hosted by Google. If you download it and you execute, the PDF. And on their hand, we got an interpreter shell. Any questions?
You said that if you just view it, it doesn't hurt it won't do anything on the system because it's hosted back basically over the web?
Yes, if you just view it on Google, then it's not going to hurt you because it's actually being hosted at Google.
Will it try to return an interpreter from whatever server it's sitting on?
No, because Google's not vulnerable to that specific attack. At least not that I know. You never know that, and he's kind of scary. Like, oh. I would get out of the InfoSec community after that one. Trust me. But yeah, no, it wouldn't execute on them. I mean, they're using their own proprietary PDF viewers and stuff like that. So, I mean, it wouldn't matter. Any questions on that so far? Well, why don't we take a quick 5-minute break while I start prepping my other demos and we'll get going. Okay.